Hello, this is Mr. Wynn, and this video is over trigonometry part 4. We're going to do word problems and applications, and this will require a calculator set in degrees mode. So now that you know how to find missing angles and missing sides in a right triangle, if you know any two pieces of information, you can now find anything in a right triangle using trig. This fourth video will focus on word problems that require both skills. The hardest or trickiest part is just drawing the picture correctly. So how can drawing a picture be hard or tricky? The answer is two specific vocabulary words: angle of elevation and angle of depression. The angle of elevation is the angle made with a horizontal line when looking up. You should be thinking of a regular triangle looking up. For example, here are two, and here are the only two possible triangles that have angle of elevations. Notice the triangles are flat on the bottom, and those bottom angles looking upwards are the angle of elevations. On the bottom, we have the angle of depression. That's the opposite. It is the angle made of a horizontal line when looking down. These have to be upside down triangles. So here are two examples, and these are the only two examples of angle of depression. This is orange angles marked on top. So downward angles with the horizontal are depression. Upward angles with the horizontal are elevation. It's very important that you know they're touching the horizontal line. And I'll show you in the next slide why. Fact, the angle of elevation and depression are actually the same. They're equal. So in this picture, this rectangle has two triangles, two similar triangles. Identify the angle of elevation at point A and identify the angle of depression at point B. So at point A, I find the angle of elevation. This right here is not the angle of elevation. A lot of kids will think that because that's all that's looking up. That's not with the horizontal. That's wrong. So this right here is the angle of elevation. It has to be a regular triangle looking up. Then at point B, find the angle of depression. A lot of kids say, is this the angle of depression right here? And that's no. Even though it's looking down, that is not with the horizontal. So that's wrong. The angle of depression is the upside down triangle looking down up there. Now those two angles are actually the same because they are alternate interior angles. Those are always congruent when you have two parallel lines and a transversal. Alright, so make sure you know the difference in the angle of elevation and depression on the picture. They're the same value because they're congruent, but they use different triangles. One's a regular triangle looking up, the one's an upside down triangle looking down. So when drawing pictures, be extra careful. You might get a weird triangle. My advice is focus on the vocabulary word first and draw that correct oriented triangle immediately. Forget everything else. Then you're going to place the sides in their corresponding parts, thinking about height and horizontal distance and nothing else. So here's a question. A boy is standing 40 yards away from the base of a building that is 80 yards tall. A girl on top of the building spots the boy. What's the angle of depression? So some people might draw this like method 1. They'll say, hey, the boy's here, and the building's 40 yards away, and then the building's 80 yards tall. We have a regular triangle looking up. And then it says, what's the angle of depression? Those people that draw this triangle like this usually say, oh, this is the angle of depression. Again, that's not the angle of depression. That's wrong. Remember, that's not the angle with the horizontal. If you choose to do this way, you have two options. You can, one, remember angle of depression equals angle of elevation and actually just find the angle of elevation. So ignore their vocabulary word. So you'd actually be finding this angle. Or two is draw the triangle or finish the rectangle actually. And then move the sides. So the bottom's 40, the top's also 40. If the right side's 80, the left side's also 80. Then you could find this angle right here. We'll call that X. So that's how you do it if you choose to do that way, which I don't recommend. What I recommend is this. My preferred method, method 2, is the moment I see the word angle of depression, I draw an upside down triangle like that. So I know that here's the angle of depression right here, that's X. Now it says the boy is standing 40 yards away from the base of the building. That just means horizontal distance is 40. So the 40 goes right here. So it's kind of weird the 40 is in the air, but it's actually the same as this dotted line right here. All right, and then the height of the building is 80. So that's vertical means 80. So here's the 80, even though that's kind of weird because the building's over here on this right side. Here's that other dotted line. All right, so I don't even do those dotted lines. So just draw the picture upside down, or draw it by the word depression means upside down, then put the 40 and 80 in the correct spot. One's the height, one's the horizontal distance. From there, we solve using our trig. We're trying to find a missing angle. So that's our reference angle. Label HAO. Out of SOHCAHTOA, which one only uses O and A? That's tangent, TOA. So we have the tangent of X equals O over A. Remember, we're trying to find the angle, so do inverse tan, both sides. because we can't do tangent of a variable. So that gives x equal tan inverse of 80 over 40. You could reduce. Maybe you have no calculator, that's your exact answer, but most of the time they want the decimal rounded approximation. So I type in the calculator, tan inverse of 80 over 40 is approximately, I use red still, 63, we'll do around hundredths place. So 2 decimals, so 4, 3, because that third 4 doesn't do anything. And the units here are yards. Not yards, degrees, sorry. Alright, there's that. So she's looking down at a 63.43 degree angle. Or you also say if the boy's looking at her, he's looking up at a 63.43 degree angle of elevation. Alright, here's another one. A 20-foot ladder leaning on a wall makes a 42 degree angle at the ground. How high up the wall does it reach? Because this is saying the ground, a ladder, ladders are leaning, so it's leaning against some building. So this diagonal is a ladder. It's 20 feet. And when you have horizontal vertical, that's 90. The angle with the ground's on the bottom, so this is a 42 degree angle. That's the same thing saying a 42 degree angle of elevation. How high does the ladder reach? Try to find x. So we have an angle, reference angle, label HAO. Of the 3 SOHCAHTOA, which one do we want to use? We have H, and we're looking for O. So which one uses H and O? That's SO. We're not using A, so we can't use KA or TOA. Alright, so that's sine of 42 degrees equals O over H. Alright, remember sine of 42 is a decimal, it goes forever. Leave it in that form. So I'm going to multiply both sides by 20, get rid of the denominator. So his left side is 20 times the sine of 42 equals x. This is the exact answer. But if they want you to approximate, type in the calculator. 20 times the sine of 42 is about, let's do 2 decimal places, 13.38. The units here is feet. So a 20-foot tall ladder, if it's leaning, of course, can't reach the full 20 feet. It's only going 13.38 feet up on the building. Here's another one. An observer in a 55 feet tall lighthouse spots a ship in distress at an angle of depression of 9.5 degrees. How far is the ship from the shore? So the moment I see angle of depression, I'm drawing an upside down triangle. So here's my upside down triangle. All right. It says the angle of depression is 9.5 degrees. So this is 9.5 degrees. That's the angle looking down with the horizontal. This is 90. It says the lighthouse is 55 feet tall. So the height, the vertical is 55. Even though the guy is actually standing right over here and the tower's right here. Ignore that. All right, the question is, how far is it from shore? So all of the ship is over here. Here's the ship. And here's water, right? And then here's the shore at the lighthouse. Ignore that. He's just asking for what's the horizontal distance. They're saying, what is this x right here? So again, just follow the vocabulary. Depression is upside down triangle. Put the horizontal in the correct spot. Put the height in the correct spot. All right. We are using this reference angle, 9.5 degrees. That's supposed to be green. All right. Label HAO. Hypotenuse is missing. Adjacent is x. Opposite is 55. Out of SOHCAHTOA, which one are we using? We have O. We want A. So which one uses O and A? O and A is TOA. Most word problems are going to be tangent, by the way. So we have tangent of 9.5 degrees equals O over A. Get rid of the fraction by multiplying by A to the denominator. Multiply by x. So I get x times tangent of 9.5 is some decimal that no one should know, except for the calculator. Then to get x by itself, you divide both sides by tan 9.5. So this is going to be 55 over tan of 9.5. That's the exact answer. But if we want to find the decimal, type in calculator. 55 divided tangent of 9.5 degrees is roughly 328.67, because that 7 bumps that second 6 up. And the units here are feet. All right, there's the approximation answer, which is usually just on the test. All right. An airplane takes off 800 feet in front of a 100-foot tall building. At what angle of elevation must the plane take off in order to avoid crashing into the building? It says angle of elevation. That means regular triangle looking up. All right, we're trying to find the angle of elevation, so this is x. The plane is 800 feet in front of the building. That's horizontal. And then the building itself is 100 feet tall. All right, so solve for x, where x is our reference angle. Here's HAO. Out of SOHCAHTOA, which one do we want? We have O and A, so we have to use TOA. All right, so it's going to be tangent of x equals O over A. Get rid of the fraction. Not get rid of the fraction. Get rid of tangent by doing arctan, so tan inverse both sides. So you get the left side is x, the right side is going to be tan inverse of 100 over 800. And you can reduce if that's your final answer, but we'll leave like that. If we know calculator, you leave like that after reducing, but they usually want the actual decimal because it makes more sense. So if I type in calculator, x is about, and I'm around 2 decimal places, 7.13 degrees. All right, so as long as it lifts off at least at 7.13 degree angle or higher, it will be above the building and not crash into it. All right, last problem and most complicated is this. A sonar on a submarine traveling horizontally detects a shipwreck 70 meters vertically below at an angle of depression of 49 degrees. A minute later, the angle of depression to the shipwreck was 65 degrees. How far did the submarine travel? So this is a multi-part problem. So we have a submarine traveling horizontally, and it detects a shipwreck 70 meters vertically down. All right, so this right here is our first triangle. It is a 49 angle of depression. Now, a few minutes later, the ship's traveling closer. Say it started here and it ends here after a minute. This new triangle right here still the same vertical height of 70 degrees, still right angle, but now the 9 degree, this is now a 65 degree angle of depression. The question is how far the trip travel, how much is this distance right here, that x, that red spot? So we're going to do 2 separate triangles here. We're going to look at, I'll do like this. The original triangle, that a 49 degree angle of depression with the 70 meters. We're going to find the total distance. To do that, to save time, I'm going to label HAO using our 49 degree angle. All right, which one uses O and A? That's TOA. So to save time, I'm not going to write SOHCAHTOA, but that's tangent of 49 degrees equals O over A. I'm going to multiply by denominator. So I get x times tangent of 49 equals 70. Then I'm going to divide both sides by tangent 49. X is 70 over tan 49. That's the exact answer, but I'm going to type in the calculator and see what the approximation is. I get a 60.85. That's how long this entire top length of this triangle is. I'm not going to focus on the little triangle, the second triangle. I'll do it over here. This is now a 65 degree angle. This is still 70. This is x. So we're still going to do, let's see, star HAO. It's still tangent. So it's still tangent of 65 equals O over A. You're going to multiply by denominator to get x times tangent of 65 degrees equals 70. Then divide both sides by tangent 65. X is 70, divide by tan 65. I'm going to type that in the calculator, get the approximation. 70 divided by tan 65 is about 32.64. So this is 32.64. To find the difference, we just subtract. So at the very end, I'm going to type this in the calculator. 60.85 minus 32.64. Final answer is 28.21 meters. So in that 1 minute, it moved 28.21 meters. All right, and that's it. Hope you enjoyed the video. Make sure you ask questions in class. Thanks for watching. See you soon. Bye. accidentally add the 6.85 to the original picture and it's 32.64. So now you can see that is segment addition or subtraction. So the whole thing minus this gives you left